This is a counting principle handout. A candy shop sells Valentine gift baskets that consist of chocolates, a basket, and a card. If there are 5 different chocolates, 3 different baskets, and 10 cards, how many different gift basket combinations are there? We have 5 times 3 times 10. That'll be 150. Your answer is C. A locker combination consists of 3 different numbers from a set of 30 different numbers on the face of a lock. Imagine that you've forgotten your combination. So 3 numbers, 30 numbers is your first. You've used the number, 29 is your second. You've used 2 numbers, 28 is your third. 30 times 29 times 28, 24, 360. Your answer is E. A license plate consists of 3 letters followed by 3 numbers, excluding 0. How many license plates can be made if no letters or numbers are repeated? So if we start off with, in our first letter, any of the 26, we've used the letter. We have 25 that we can choose from. We've used 2 letters. We have 24. That's our 3 letters. Our numbers, we can't use 0. So we can use anything besides 0. So there's 9. Can't use that number we just used, so now you're down to 8, and you're down to 7 for your last number, and that is D. Sam is getting dressed in the morning and has 6 pairs of pants, 4 shirts, and 5 pairs of socks. How many distinct combinations? So 6 times 4 times 5, 6 times 4 times 5, 120. Susie wants to make a sandwich for lunch. She has 2 types of bread, 3 types of meat, and 2 types of cheese. 1 of each ingredient. So 2 bread, 3 meats, 2 cheese. 2 and 2 is 4. 3 makes 12. Your answer is E. How many different 5-letter computer passwords are possible, assuming that the letters cannot be repeated? So 5 letters. You have 26 choices for your first letter. You've used the letter, you're down to 25, down to 24, down to 23, down to 22, and that would be 5 letters. Seven, 8, 9, 3, 600. Your answer is B. At a party with 9 guests, every guest shakes every other guest's hand exactly once. So you have 9 people. You're one of the 9, and you are going to shake 8 other people's hands. Now the problem with just that is if I shake your hand and you shake my hand, that's counting as 2 different handshakes. We want to eliminate that overlap, and you do that by simply dividing by 2. 9 times 8 is 72. 72 divided by 2. 36 handshakes. So the number of guests minus 1 of those guests, and you divide that by 2. Ashley is modeling a new mix and match clothing line. Her stylist selected 5 tops, 3 skirts, and 4 jackets, and it's going to be 1 of each. So 5 times 3 times 4. 5 times 3 is 15. 15 times 4 is 60. Your answer is E. 20 people shake hands with each other. So these are some open-ended questions I created. 20 people shake hands, so that'll be 20 times 19 divided by 2. 20 divided by 2 is 10. 10 times 19 is 190. There you go. If 15 people are in a room and each person shakes hands with every other person, 15 times 14 divided by 2. 105. At a party, everyone shakes hands with each other. There are 45 handshakes. So I'm going to have to work this one backwards. So remember how I got the 105? Remember how I got the 190? I took a number and I divided it by 2. So if 45 is my final answer, then that means I need to multiply that by 2, and that's the number I need to get to divide by 2. In order to get 90, I'm thinking of a couple of numbers that when I multiply them together, they got to be side by side. I'm thinking 10 and 9. 10 people were at the party. They shook hands with 9 people. Your answer is 10. If a polygon has 42 sides, believe it or not, the polygon diagonals is exactly like handshaking. 42 sides on a polygon times 41, divide that by 2. So now you know how to do the classic handshake problem and the classic diagonals of a polygon. 42 times 41, divide that by 2, 861 diagonals.